I had problem number 38 from chapter 7. My problem asks me to describe the change in hybridization, if there is any, of the aluminum atom when aluminum trichloride AlCl3 interacts with a chloride ion to form AlCl4-. The first step I took in order to determine the change in hybridization was to draw Lewis structures of AlCl3 and AlCl4-. In order to draw the Lewis structures, I determined the number of valence electrons for both AlCl3 and AlCl4-. Since Cl is in group number 7, it has 7 valence electrons, and aluminum is in group 3, therefore it has 3 valence electrons. The same goes for both aluminum and chlorine and AlCl4-. The total number of valence electrons in AlCl3 is 24. Once I subtracted the number of electrons for each bond, I had a total of 18 valence electrons left. Once distributed to each chlorine atom, I had no more valence electrons left. In AlCl4-, I had a total of 32 valence electrons. 1 electron is added because it has a -1 charge. Once I subtracted the number of electrons for each bond, I had a total of 24 valence electrons, and once they were distributed to each chlorine atom, I had no more valence electrons left. Looking at each structures, AlCl3 has a trigonal planar geometry, whereas AlCl4- has a tetrahedral geometry. According to the geometries, you can determine the change in hybridization of the aluminum atom. In the AlCl3, it has an sp2 hybridization, whereas in the AlCl4- it implies an sp3 hybridization. Therefore, there is a change in hybridization of the aluminum atom when aluminum trichloride AlCl3 interacts with a chloride ion to form the AlCl4-.